In this video, we are going to be dealing with a topic in maths, logical reasoning. And we are going to start with logical statements because it is from logical statements that we actually make logical reasoning out of it. So for this topic, why are we studying it in maths? Why do we need to know that this statement implies this statement? We actually make use of logical reasoning when we come to subjects like computer science or computing itself, law, even in scientific deductions. So that is why we study them. So I will pay attention to find out how to work around statements, to find which ones are equivalent, which ones implies this, which ones are their negatives, and other things we are going to learn from the topic. So we start with logical statements. A logical statement is a sentence or declaration that is either true or false, but not both. So we are making statements. For us to recognize statements, we have to know whether they are true or false. If a statement is neither true nor false, or could be true or false, then that doesn't sound like a logical statement. And it may be a declaration, so it could be said, it could be written. So, okay, so let's use these examples here to recognize how do we know a statement when we see it. Remember, we said that a statement, a logical statement is a sentence that is either true or false. So we go. Nigeria is a populous country. A populous country. That means we have so many people in Nigeria. That is, it has a large population. So let's see. Okay, it's a statement because we could verify whether it is true or not true. In which you could say it is true, right? There are many people in Nigeria. Okay. Ghana is a country in Africa. Is this a statement or not a statement? So let's see. Ghana is a country in Africa. We could verify whether it is true or not true. It's either true or not true. It's either Ghana is in Africa or Ghana is not in Africa. So when we look at it, but we know Ghana is a country in Africa. So this is a statement. She is a beautiful girl. Okay, she is a beautiful girl. We need to see the girl to actually know whether she's beautiful, but this is a verifiable statement. We could look at the girl referred to and then be able to say she is beautiful or she is not beautiful, though beauty is in the eye of the beholder. You could see someone that is beautiful and then someone else says, no, I don't know what you're thinking. She's not a beautiful girl. So it could break the girl's heart. But that aside, this is also a statement because we could verify whether this girl is beautiful or she's not beautiful when we see her. Okay, then this statement that we have to decide by seeing the girl, and it is like conditional because some people they have a definition of beauty and some people they have a different definition of beauty. This kind of statement leads us to something we call open and closed statements. So for open statements like this, we don't know the conclusion. But there are closed statements like these two. The first two we've seen are closed statements. We can just look at the statement and we'll be able to know this is true, this is not true. But for this one, we can't say, we don't know the girl they are referring to. We need to see her to confirm that she is a beautiful girl. Okay. So we go over. 2 plus 7 is equal to 3. 2 plus 7 equal to 3. This is a mathematical statement, right? Because we've even said it in a sentence that 2 plus 7 is equal to 3. Any equation is a statement. A mathematical equation is a statement because you're stating something on this side is equal to this, or even an inequality equation, an inequality statement. Yes, we are. So let's see. Can we say whether it's true or false? It's false, right? We can even see 7 over here. It can't be equal to 3. It can't be. Even if we subtract 2 out of it, it can still be 3. So this is a statement and we could say whether it is true or whether it is false. Number 5 says, are you going out? So this, is it a statement or not a statement? Are you going out? Can we say whether it is true or false? Nah, we can't say whether it's true or false. It's a question. It is not a statement. We can't even start knowing whether it's true or false. It's just a question asking to get information. Okay. Number 6 says, stand up. Is it a statement? Can we say it's true or false? Okay, we can see we can't even say whether stand up is true or false. It's a command. So it's not a statement itself. So these ones are statements. A statement, we can verify whether it is true or false. But these ones, we can't know. There is no how you can know whether are you going out is a true or false thing. It's a question. It's a command or a request. Okay, 4 is less than 5. We can see this mathematics again, mathematical statement. So this is a statement. We can find out if 4 is less than 5, and we can actually see it is a true statement. 4 is actually less than 5. A rectangle has 4 sides. We know a rectangle, right? Or do I need to draw it? Okay, let me draw, in case some persons have forgotten what a rectangle actually looks like. But we can't forget it, right? Those are the basic shapes we learned when we were in nursery school. So this is a rectangle. A rectangle has 4 sides. It's a statement. We can verify whether it is true or not true, or we can draw it to find out it has 4 sides. Will she attend the event? We can already see the question mark telling us this is a question, not a statement. So we can't verify whether it is true or not. Okay. John is the tallest boy in his class. John is the tallest boy in his class. This is a statement because we can know whether it is true or not when we see John and we see the boys in his class and we find out whether John is actually tallest. So this is a statement and it is an open statement. We can't just say whether it is true or false. We need to see John. We need to see his class boys and we compare them to find out whether it's true or false. So we go over to these two. Lagos is the capital of Nigeria. Lagos is the capital of Nigeria. We can see that we can verify whether it's true or false. We can come into Nigeria and check what's the capital of Nigeria, or call a Nigerian and ask what's the capital of Nigeria. Okay, so Lagos is the capital of Nigeria. Is it a statement? Yes, it's a statement. It's verifiable whether it's true or false. But it's a false statement, right? But this kind of statements, we can't. Some years ago, some many years ago, this was a true statement. Lagos was once the capital of Nigeria, but it's no longer true. So some statements that were true before may not be true anymore. Okay, it's just for us to take note of that. Uranus is a planet, so this is just like the previous one, is a statement, but for us to verify, is it a true statement, is it a false statement? Noun, this is a false statement, noun. But years ago, like before 2000, this was a true statement. Uranus was a planet, but now they said it's a subplanet, or I don't know, but Uranus is no longer a planet. Therefore, a statement can also come, there are 9 planets in our solar system, and we'll say, nah, that used to be true, but now is no longer true. So now that we can find out whether a sentence or is a statement or not, and we can also know true or false statements, we use capital T for true and capital F for false. So we want to see negation of a statement. When we see a statement, can we negate that statement? Can we? Negation is just to say, this is not it. This is long, this is not long. So that's negation. So how do we write the symbol for negation of a statement? So we can say if A, for example, is a statement, because statements we could symbolize them with capital letters or small letters as the case may be. So if A is a statement, its negation is going to be not A. So we can use this symbol. So this is A, this is not A. Or we can say bar A to represent this is not A. Or we can say A prime to say this is not A. So this is the statement, this is the symbol representing the statement, and this is not A. And then statements, we can also use small letters like maybe P, for example. So if this is a statement, we can write its negation as not P, bar P, see me repeating A, bar P or P prime, to show that this symbol says this is this, and this other symbol will represent this is not this. So write the negations of the following statements. So let's use these examples to learn how to write negations of statements. Mary is a teacher. We can say Mary is not a teacher to negate that. Or we can say it is false that, we now put in the statement. So those are the two major ways of negating a statement. It is false that Mary is a teacher. Mary is not a teacher. So using not is a very, very easy way of negating a statement. It is false that is also a good way of negating a statement. Then there are other ways of negating a statement, but we'll look at it. But those other ways requires absolute carefulness. So the negation of this, I wish I used letters to represent this, so that I'll now use this kind of symbol to represent the negative statements. Okay, so its negation is that Mary is not a teacher. Or we can say it is false that Mary is a teacher. The plate is clean, so we can say the plate is not clean. That's right, I can already hear you saying it. Or it is false that the plate is clean. So for this one, we say 4 is equal to 2 plus 1. So its negation will come as 4 is not equal to. So you write equal to, you cancel it out. This is not equal to 2 plus 1. And one other thing we need to also know is that when a statement is true, its negation is going to be false. When a statement is false, its negation is going to be true. Just like this one we just saw here. 4 is equal to 2 plus 1. So when we check this other side, 2 plus 1 is actually 3, right? So it's not equal to 4. So this statement was false. Its negation now is a true statement. 4 is not equal to 2 plus 1. So you can see that. The milk is sour. So we can say the milk is not sour, or it is false that the milk is sour. She scored the highest mark in the exam. We can say she did not score the highest mark in the exam, or it is false that she scored the highest mark in the exam. Though some people might say, let us change this to its opposite, so highest to lowest. She scored the lowest mark in the exam. But let's look at it objectively. She may not have scored the highest mark. That is when we look at the negative statement now. But she may not have been the lowest. So that is why I said, apart from using those two, not and it is false that, to use other negating a particular word in the sentence may not always be a perfect negation of that statement, just like this example. He is intelligent. He is not intelligent is the negation, or it is false that he is intelligent. If we say he is dull or he is dumb, that may not cover it. He may not still be intelligent and still be kind of okay. She doesn't study physics, so we say she studies physics. Or it is false that she doesn't study physics, because this doesn't now is a negative statement, like when it stands on its own. It does not, so it already has the not. So when we remove the not from it. She studies physics. She does study. No, that doesn't sound right. She studies physics. Is a negation of this statement, or it is false that she does not study physics. So we can see it is false, it's a negation, and this is a negation. So that negative and negative has cancelled out to give us a positive value. It is false that she doesn't study physics, or she studies physics. 6 is an odd number. We can say 6 is not an odd number. It is false that 6 is an odd number. Or we can change this word. 6 is an opposite of odd is even. So we can say 6 is an even number. And when we look at these objectively, we could see that yes, odd and even are opposite words of each other. And when we place it here, it actually negates this. There is no other in between. Why we didn't use it for this was because this highest has some values in between it. There is a value between highest and lowest. There are values in between. But a number is either odd or even. So those kind of opposites are those words that we can actually change to do negation of numbers. Okay, 7 is greater than 8. So we can say 7 is not greater than 8. So we write it this way. 7 is not greater. So we write the greater and we cancel it out. Is not greater than 8. Or can we say 7 is less than 8? There are some cases where this will not work. 7 is less than 8. There are cases whereby when we put the opposite of this, it may not work. John was present when it happened. So we can say John was not present when it happened. It is false that John was present when it happened. Or we can say John was absent when it happened. So there is no in between for present. You're either present or you're not present, or you're absent. So opposite of this word could actually change it. So in this video we've learned to recognize statements, and we've learned true or false statements or open statements that we can't confirm whether it's true or false at the go. And we've also looked at how to negate statements. So for the next video, we are going to be looking at other aspects of logical reasoning.